Hello everyone, thank you for coming here. I'm Wen Zhuo. I'm from Nanjing University of Aeronautics and Astronautics. The topic of my presentation is prediction construction industry safety performance based on AHP and the grid system. My presentation includes these four parts: the introduction of our research, the model we have proposed in the paper, the applications and results of the model, and the last, some conclusions we have got. Let's start with this figure, which shows the safety excellence of building construction and municipal construction engineering in China from 2010 to 2019, and the excellent data from 2020 to 2021 have not been made public because of some responsibility division problems. As you can see, despite a couple years of decline, there is an overall upward trend. Not only in China, casualties from construction accidents have been a problem that has plagued the world. So, it's urgent to predict construction safety performance. This is also the main purpose of our study. It can be found that researchers are trying to combine multiple methods to improve the accuracy of construction safety predictions. This is a valid direction for research. However, many researchers have not focused on safety performance as a complex variable affected by multiple factors. Prediction accuracy can be improved by analyzing the variable and its influencing factors together. Meanwhile, the time series has a principle of nearest greater and far is less. That is, the future trend of time series data depends more on the past data close to it. Considering the 2 points of departure, this study used influencing factors to predict safety performance and took into account the relative importance of time series data for each year. The main process of this study is carried out according to the figure. Firstly, the indicator and its influencing factors were identified by the literature review. Secondly, the analytic hierarchy process, group relational analysis, and the GM1M model were used to construct the prediction model. Then, the collected data was applied to the model. Finally, conclusions were drawn. Research on construction safety varies in different national contexts. Therefore, the literature collection of indicators and factors was mainly in China. It's more suitable for the Chinese construction industry. Group relational analysis measures the degree of association between factors based on the similarity of trends. In this study, GRA was used to calculate the group relational degree between the influencing factors and the indicator to select the final factors for prediction. The analytic hierarchy process is a method for analyzing decisions by factoring in weight. Since the time series has the above-mentioned principle, in this study, AHP was used to calculate the relative importance of each year. It's worth noting that in group relational analysis, the weights of all years are the same, which is not in line with the principle of time series. So, this study used AHP to optimize the group relational degree. Group prediction theory transforms the original sequences into regular sequences and then predicts future data. As one of the group models, the GM1M model is composed of the system characteristic sequence and the factor sequences. It's more effective for the prediction of complex systems. So, in this study, the GM1M model was used to predict construction safety performance. Statistics were obtained from information publicly released by the Chinese government. Due to the division of responsibility mentioned previously, this study selected data from 2013 to 2019 for the application of the model. Now we move to the part of the application. After the calculation of the relative importance and the optimized group relational degree, it can be seen that there are 4 factors with group relational degrees greater than 0.8. So, these 4 factors were selected as the factor sequences for prediction. Then the predicted results were calculated by GM1M model due to the shortcomings in the mechanism, parameters, and structure of the grid model. The predicted results sometimes show fluctuations, resulting in the model failing to obtain accurate predicted results. Therefore, it's necessary to remedy the original model to improve the accuracy. As shown in the right figure, the prediction error was reduced after modification and showed a gradual decrease. There was a high overlap between the actual and predicted data from 2016 to 2019, indicating that the prediction effect was great, and the accuracy was gradually improving. This study helps to plan the necessary actions and measures to ensure the smooth running of projects. By controlling the influencing factors that are strongly related to safety performance, the occurrence of safety accidents can be reduced. At the same time, the constructed model promotes the development of predictive models. It also provides a method for predicting construction safety performance using time series data. However, there are still some limitations. The grid model has the characteristics of small samples. It's difficult to predict large samples in a long time range. Therefore, improving the prediction effect of the model requires further research in conjunction with the characteristics of the construction industry, rather than increasing the prediction years of the data. At the same time, it can be found that this prediction model can only predict the number of accident fatalities for the year based on the influencing factors. In the future, we will predict the future influencing factors and then to predict the safety performance based on the factors. That's all for my presentation. Thank you for listening.